In this lecture, we are going to learn about the two-dimensional array. To understand two-dimensional array, first let's talk about 1D array, also called as one-dimensional array. Let's say I would like to collect the marks of a student number 1 in 3 different subjects. So there are 3 subjects for which he has received marks. So I'd like to store those marks, right? So in that case, I can create an array called as like A. I can write int A and give the size as 3. If I do this, I create an integer array A of size 3. So it can hold 3 integer numbers, 3 marks. Let's say the marks are 36, 82 and 90. Okay, so this is called as a one-dimensional list because it has just one direction. It can only go in this direction, right? It is only having one direction. So we just need one index to access the element. So index starts from 0 and then 1 and then 2. Okay, so because it has only one direction to go, it is called as one-dimensional array. Now let's move into what is two-dimensional array. Now if you have understood one-dimensional array, that it has only one direction. So in two-dimensional you have 2 directions, one this side, left or right, and one up or down. So this is two-dimensional array. It has 2 dimensions, right? So to easily understand two-dimensional array, you can think two-dimensional array as the collection of one-dimensional array. Okay, let's say I have 3 such students. So this is just one student, right? So I have one more student who is having 3 different marks. So let's say he is having 3 different marks like this. This is like 16, 32 and 90. Let's say the score is out of 100. This is for student 2. This is the list of marks for student 3 in 3 different subjects. Let it be 82, 16 and 92. Okay. Now if we see here, I put all this together in a single place, right? So I call this entire thing together as a two-dimensional array because it has 2 dimensions. One is called as a row, which is having the marks of each student, right? So I say this is the first row having the marks of first student, this row is having the marks of second student, and this row is having the marks of third student. And I have one more dimension, that is the column, right? Now this column is nothing but the marks in an individual subject. Like let's say this is math. This is the marks in math is stored in this column. Let's say this is the marks in the subject English stored in this column, and let's say this is the marks in computer science stored in the third column, right? So I say this array now becomes a 2D array because it has 2 dimensions, because it is the collection of 1D array. So I can say that this 2D array is the collection of 3 1D arrays, and each of the 1D arrays is having the dimension or size of 3 elements. It is having 3 elements. So this is two-dimensional array. Okay. Now let's learn how we can define our own two-dimensional array. Defining a one-dimensional array is very simple. First you give the name of the data type, and then you give the name of the array and the size of the array. How many elements are there in this array? That is the size. Okay. So here I say this is the integer array. I write the data type as int. Name of the array is A, and 5 is the size of the array. So it will reserve 5 blocks for storing 5 different integers, index starting from 0 to 4. This is one-dimensional array. Now the syntax for defining two-dimensional array is very similar to one-dimensional array. First of all, you write data type. What is the data type? What is the type of your data? Okay, so data type. Always array, remember array is the collection of data of same type. Okay, all the elements should be of same type. That for even applies in 2D array as well. Okay, so first you write data type, then you give the name of the array, the same syntax, name. Okay, then you have 2 subscript open here like this. One subscript for the size of row. So I said I wrote this as row. This is the size of the row. How many rows are there? And this is how many columns are there. This is the size of columns. Okay, these are integer numbers. How many rows? How many columns? So these are actually unsigned integers. So there should be a positive number, right? Let's say I would like to create the array of size 2 rows and 3 columns, right? So how do I do that? It's very simple. First data type is int because I'm trying to create the integer array. Name of the array, let's say it is A. How many rows? I want to have 2 rows, and how many columns? I need to have 3 columns. So whenever I do this, I create a matrix kind of a thing. Okay, so it is going to have 2 rows. Okay, this is first row and this is the second row. Okay, let's say, and there are 3 columns. Okay, this is 3 columns. So this looks like a matrix, isn't it? Now as in 1D array, index always starts from 0. Okay, so this is row 1. The first row is indexed by row value, index value 0, and the index for the second row is 1. Similarly, each column is going to have its own index. So index for the first column is 0, and then 1, and then 2. Okay, so in this array there are 6 elements, right? So these are the elements. If I don't write anything here, it would be holding the garbage values. So all these values are garbage values. Okay, but if I would like to assign values to this array, what I can do is, well, actually defining this array, I can actually write here equals to, I give a bracket like this and then write 1 2 3 4 5 6. So in this case what is going to happen is that 1 is going to be stored here, 2 3, so row by row it will be stored, then 4 5 6. Okay, so this is how it is going to be stored. Now how do I access the element? That's very important, right? So how do I access this element? So to reach to this element, first I have to reach to this particular row. So the row index is 0 and the column index is 1, right? So I write, so the name of the array is A here, so I write A is the name of the array. Then I have to have 2 subscript for accessing the element, right? So the first subscript here is 0 and that is the row index, and the second subscript is the column index, that is 1. Okay, so if I write A01, I mean I go to the row 0 and then I go to the column 1. So row 0 column 1 the value is 2. So A01 is nothing but the value is 2. Okay, similarly how do I access this element? So I have to write A, name of the array, row index is 1 for this is there in index 1, row index 1. And what is the column index? Column index here is 2. So if I write A12, I mean I'm trying to access this element 6. Okay, this is how you actually access the elements in a 2D array, right? Now we have already seen how we visualize a 2D array like this, having 2 rows and 3 columns. Okay, there are 2 rows here and there are 3 columns here, right? This is column 1, this is column 2, and this is column 3. Okay, now this is how you actually can assign the value while actually declaring the array itself. Okay, and this can be done in this way as well. Okay, I can write this as 1 2 3 in a curly brace and then give a comma and write 4 5 6. Okay, now whenever you look at this 2D array, you have to look from a different perspective. You don't look it as a matrix, right? It is actually not going to be stored in a matrix form in the memory. In the memory it is going to be stored flat like a 1D array. Okay, it is going to be stored sequentially in the contiguous memory location. They will be coming one after the another in the memory, and it is not going to be stored in a matrix form like this in the computer's memory, right? So if you try to visualize this array, whenever I say 2, I don't say that there are 2 rows. Now we say that there are 2 elements in this array, right? So let's put this element in this array. This is the array A. Okay, the elements are 1 2 3 4 5 6. I don't say there are 6 elements in this array, because this dimension is 2 here. This means there are 2 number of elements in this array. There are just 2 elements in this array. The first element is this 1D array, and the second element is this 1D array. So there are 2 elements in this array. Now each of these element is having the size of 3. So this 3 indicates the size of my 1D array. Okay, and this 2 indicates how many such 1D arrays are there. So in this array A, I say this is a collection wherein there are 2 1D arrays. There are 2 elements, right? So this is the first 1D array, this is the second 1D array. Each 1D array is having 3 elements, right? So this way if you think, it will be easier for you to visualize. Now in the computer's memory, these elements will be arranged sequentially, and there is no concept of indexes while the element is stored physically in the memory, right? It only has got the address. Indexes is for us to understand how to access the elements of the array, right? But while it is being stored in the memory, index is not going to be stored. Just remember that. Okay, because each of these elements are of integer type, and let's say that each integer takes 4 bytes memory. Okay, 4 bytes of space in the memory. So what is the space requirement for this entire array is 6 elements are there. So I say 6 into 4, it takes 24 bytes in total. In the memory it occupies 24 bytes, but it is not going to be stored as in the index form in the memory. Each of these element is going to have its own unique address. That is how we actually access the element. Okay, so this is how it is being stored in the memory in a flat form, as in a continuous memory location, right? One after another in the memory they'll come. Okay, this is how it is being stored, and it is not going to be stored in a matrix form. This is just the form for us to visualize how it is actually accessed. Okay, this is the logical view of this array, and this is the physical view, as in the memory how it looks like. This is how it looks like. Okay, but for us it is easier to visualize the array and access and manipulate the array if you visualize the array as the matrix. Okay, so this is how you represent the array or 2D array in the memory. Okay, now let's try to see how we can access the element of this array, okay, using a loop. Okay, because this is a 2D array, right? Here we have 2 dimensions, so obviously you may be guessing it, right? We'll be needing 2 loops, right? One loop for accessing the row and one loop for accessing the column. Okay, now let's say I ask you to solve this problem, like you are supposed to find out the sum of all these elements in this array. So there are how many elements in this array? If you count individual integer numbers, how many are there? There are 6 numbers, right? So I add them together and I have to display the sum. So what I do is, I'll first of all, let me have this variable sum, okay, int sum initialized to 0. Whenever I catch hold of a number, I'll add that number to this variable sum. Okay, now first of all, I need to have a loop, a for loop, obviously. Okay, now for loop will take care of rows. Now how many rows are there in this array? So there are 2 rows. This is the first row, okay, this is the second row. Okay, so for, I'll write I, let's have this variable I and j also declared. Okay, for I equals to 0, first index is obviously is index 0 and the second index is 1. Okay, so I must be less than 2. 2 is nothing but the size of the array. Okay, number of elements in this array. So I say in this array there are 2 elements, right? There are 2 1D arrays. If you see here in the view, right, you see there are 2 elements, the red boxes, there are 2 red boxes, right? So the first red box is having the index 0, right, and the second red box is having the index 1. So whenever I write a 0, I mean I am in this particular row, the first row or first 1D array, and whenever I write a1, okay, I am in the second row or this particular 1D array having the element 4, 5 and 6. Okay, now if I am in the first 1D array, I have 3 elements, so each element is having its own index starting from 0, because this is a 1D array. Now whenever I reach here, now this becomes a 1D array, right? Now if this is a 1D array, if I put index 0, if I write a0 0, I am reaching to this element, right? If I write a0 1, so a0 will take me to the first 1D array and a0 1 will take me to this particular element. Okay, so similarly the indexing is done. So I have 2 rows. So first loop, the outer loop will take care of rows, because I have 2 rows. I'll go up to less than 2, so index 0 and index 1. Index 0 is the first row, index 1 is the second row. Each time I increment the value of I by 1. Okay, this will make sure that it runs a loop for the entire rows of my 2D array. So there are 2 rows. Now I need to run one more loop. Let's call it as a j loop. Okay, for j, obviously if you look at each 1D array, the index starts from 0, isn't it? Each 1D array, the index starts from 0 and it goes up to less than 3. 3 is nothing but the size of my column. Column size is 3, and then I write j++, because I have index 0, index 1, index 2. There are 3 columns, right? If the size, so if for this number of rows is 2, number of columns is 3. Okay, so I'll go up to less than 3. 2 is less than 3, so I write j less than 3, j++. Okay, this is the inner loop. Okay, now how do I access the element? I access the element by writing a I j. Okay, so a I j will help me to access the element. So initially whenever I is 0, it will be a 0 and j will be changing from 0 to 2, so it will be a0 0. So this is I, this is j. Okay, so this is a0 a1, this is a0, this is a2. So this is how you access the element a00, a01, a02. Similarly a10, a11, a12. So it will catch hold of all these numbers one by one once this loop runs, this nesting of loop runs. Now this will be having the access of the element. So I'll write my sum would nothing but the previous sum, whatever it was, plus this number a ij. Okay, so I'm catching hold of each of these numbers and adding to my sum. And finally, once I am done, I'll come out of this loop and then I can display this sum just by writing printf %d sum. So if I display the sum, it will display the sum of all these numbers. If I just add 6 plus 4 10 plus 5 15, 15 plus 5 is 20, 20 plus 1 is 21. So the sum that is displayed is 21. Okay, so this is how you can actually access the 2D array using a loop. Okay, so in this lecture we have learnt about what is a 2D array. Okay, how to represent a 2D array in the computer's memory, what is the physical view of the 2D array, and what is the logical view of the 2D array, what are the indexes, how you can access the index, the row index and the column index. And finally we have learned how to access the 2D array using a nested loop, one loop for taking care of the rows and one loop for taking care of the column. Okay, so that's all in this lecture. Stay tuned for the next lecture on the two-dimensional array.